Okay, so hi Math Contest Club members. So right now I'm gonna do the video solutions to the worksheet from November 1st and 3rd. So the questions are from AMC 10 and 12, so they are pretty hard. Don't feel worried if you didn't get them correct at the first attempt. And I will start with the fourth question. So Una rolls 6 standard 6-sided dice simultaneously and calculate the product of 6 numbers obtained. What is the probability that the product is divisible by 4? So we need to think about when a number is divisible by 4. So a number needs to be divisible by 4 when there is at least a 4 as its factor. So 4 is also 2 to the power of 2, which means there are 2 2's. In its factors. And we think about a die. So a die is 1, 2, 3, 4, 5, 6. There are 1, 3, 5, which are odd, and 2, 4, 6, which are even. So there are 3 odd numbers and 3 even numbers. And we think a scenario that if we get the 6 numbers that are 1, 2, 2, 3, 3, 5, 6, and this is divisible by 4 because there are 3 2's in this product. 1 is here, 1 is here, and 1 is here because 6 equals to 2 times 3. And this is divisible by 4. And in the other case, there are only 1, 2, and this is not divisible by 4. And in the worst case, there's 0, 2. It's also not divisible by 4. And right now, we just need to think about how many ways are there for just no 2 or only 1, 2. So we consider 0, 2 at first. So for 0, 0, 2, every die we roll, it should be all odd numbers. And the probability that we get an odd number is 3 out of 6. And because there are 6 dices, we should have 3 out of 6 to the power of 6. And we think about 1, 2. So there's only 1, 2. We can just do 2 out of 6. And why is 2 not 3? Because only 2 and 6 can be the case. 4 is not the case because 4 itself contains 2 2's. And 2 out of 6 times for the others, it should be odd, which is 3 over 6. And to the power of 5. And we can see here, the 2 can actually be placed at any number. So the 2 can be here, 2 can be here, 2 can be here, 2 can be here, 2 can be here. So we need to time 6. And this gives us the answer 7 out of 64. 64. And we know that this is the probability that the product is not divisible by 4 And to get the probability that is divisible by 4, we just use 1 to minus 7 out of 64, which is answer B, 57 over 64. Okay, the second question, consider two concentric circles with radius 17 and 19. The larger circle has a chord. Okay. So the concentric means they have the same center of circle, and half of which the chord of the large circle, half of which lies inside a smaller circle. And what is the length of the chord in the larger circle? So we first draw a chord, and we connect the center of the circle to the chord, and then we draw a perpendicular line to the chord. And because of symmetry, we can say this part is x and this part is also x. And because given the smaller chord is the half of the larger chord, we can see that this is also x and that is also x. The radius 19 for the larger one, the radius 17 for the smaller one. And because here it's a right angle because of the perpendicular line, we can use the Pythagorean theorem. And we find out that in this triangle and this triangle, they share a side, which is this one. And now we can apply the Pythagorean theorem by 19 squared minus 2x squared should be equal to 17 squared minus x squared. And we just solve for x. So there's an easier way to solve it without a calculator. You can simply move the constant number to one side and the x variable to one side, which gives us 19 squared minus 17 squared equals to 3x squared. And because of the formula that a squared minus b squared should be equal to a plus b times a minus b, this part should be 19 plus 17 times 19 minus 17 equal to 3x squared. And 19 plus 17 is 36, 19 minus 17 is 2, so 36 times 2 equal to 3x squared. And in this case, x squared equals to 24, and x is 2 times square root of 6. And the length of the chord of the larger circle is 4x, thus equals to 8 times 6 squared. Now let's get on to the last question. There are actually a lot of ways to solve this one, and I will just do it through the most intuitive way. So basically it's just do the case analysis. So for how many other pairs of BC of positive integers does neither x squared plus bx plus c equals to 0 nor x squared plus cx plus b equals to 0 have two distinct real solutions? And if you have learned about quadratic equations, we know that when delta is smaller or equal to 0, the equation does not have two distinctive real solutions. And the delta is given by b squared minus 4c. And for this equation, it's c squared minus 4b. So c squared minus 4b smaller and equal to 0, and b squared minus 4c smaller and equal to 0. And we can first square the second inequality, and we get b to the power 4 smaller than 6 times c squared. And then we can multiply this first inequality by 16, and now it's 16c squared smaller than 64b. Now we know that b to the power 4 is smaller than 16c squared smaller than 64b. And we just do case by case, because b and c's are positive integers. So when b equal to 1, we know that 1 is smaller than equal to 16c squared, smaller than equal to 46, and c can only be 1 and 2 in this case. Let's continue. When b is 2, the inequality is here, and c is also 1 or 2. And when b is equal to 3, the inequality given is here, and c could be only 3. And if b is 4, then the inequality here is like this. And c can only be 4 in this case. And b cannot be 5, because when b is 5, the number gets to 625 smaller than 16c squared and smaller than 320, which doesn't make sense. Therefore, b should be smaller than or equal to 4. And thus, there are only 6 pairs of integers of BC, and they are 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. Okay, so here's the end of the video, and thank you for watching the video. And AMC B is taking place on November the 16th, so good luck everyone who signed up for it. Do more practice, and I hope you have learned something new from the video. See you next time.